acid, base and salt. We have completed this chapter very well. Now today we will do the revision of the chapter number 2. So what we have discussed in our sessions, just have a look on it very quickly. First we have discussed about what is called acid. So acids are sour in taste and it converts blue litmus paper into red. On other hand, base is bitter in taste, and as we all know that it will be opposite than acid, so base converts red litmus paper into blue. But as we all know that here it will not affect on red litmus paper and blue litmus paper is not going to get affected by base, right? So this common concept we have understood about acids and understood about base. After that we have checked the chemical characteristics of acid. So chemical properties of acid. In chemical properties, what we have discussed? We have discussed like this, that acid plus metal, it gives us salt and dihydrogen gas. Let's take one example of it. HCl plus Zn, it will give us ZnCl2 plus H2. Similarly, H2SO4 plus Zn gives ZnSO4 plus H2. So this was our first characteristic of acid, that acid plus metal gives salt and dihydrogen gas. The another characteristics was like this: acid plus metal carbonate or metal hydrogen carbonate. It will give us salt plus water plus carbon dioxide. Let's check one example. H2SO4 plus metal carbonate. Here we will take Na2CO3, which gets resolved into salt, NaCl plus H2O plus CO2. Now let's check. Here there is 2. Sorry, here we will get Na2SO4, right? H2SO4 plus Na2CO3. So this will move towards SO4. So it will give us Na2SO4 plus H2O plus CO2. If we talk about HCl plus Na2CO3, it will give us NaCl, right? NaCl plus H2O plus CO2. So here will be 2 more of it, and here also it will be 2. So this is our second characteristic of acid. You can also take metal carbonate or metal hydrogen carbonate. The third characteristic is when acid reacts with metals oxide, it gives us salt plus water. Let's take an example, HCl plus metals oxide like Na2O. It will give us NaCl plus H2O. 2Cl, we will get it like this. So this is our third characteristics, that acid plus metal oxide gives salt and water. Fourth one, acid plus base also gives us salt plus water, and this process is called neutralization reaction. HCl plus NaOH gives NaCl plus H2O. or you can take H2SO4 plus KOH gives us K2SO4 plus H2O. So this is our fourth characteristic of acid. This reaction is also called neutralization reaction. So what is called neutralization reaction? This type of question can be asked to you. In that we will write that when acid reacts with base, and in that reaction they will nullify their effect and will result into salt and water. So that reaction is called neutralization reaction. Or it is called titration reaction. So this way, chemical properties of acid I have explained. Chemical properties of base is also the important question, right? In that what we will have acid plus base gives salt and water, that is there. In second property we will have base plus non-metals oxide, it will give us salt and water. And base, when it reacts with water, when it reacts with metal, it will give us salt of it. Like we have taken the example that zinc. When zinc, it is a metal and it reacts with base NaOH, it will give us sodium zincate. Formula of sodium zincate is also very important for your exam. Right? So this way we can go. From all this thing, what conclusion we will get? We will get like this, that the metal oxides are always base and the non-metals oxide are always acidic in nature. So they are acidic. Chemical properties of base, that's easy, right? And then you are going to do it by yourself. I have explained the chemical properties of acid. Similar to chemical properties of acid, you can also do chemical properties of base or of alkaline. That you are going to do it by yourself. Now, how to know whether the compound is acidic or basic? For that we were using indicators. Yes, you are right. We have understood about different types of indicators. Now, let's see that how many types of indicators we have. We will have natural indicators, synthetic indicators, olfactory indicators, and universal indicators. Right? Natural indicators that we know very well that it is obtained naturally. Synthetic indicators prepared in lab or in company. Olfactory indicators which changes its smell when it comes in contact with acidic substance, and universal indicator by adding that universal indicator in any of substance according to the concentration of H plus and OH minus, it is going to give us different color, and by that universal strip we can identify the range of its pH. Yes. Now, what do we mean by this pH? As we have studied that pH scale, in that P stands for potence, and in Greek that potence means power. The power of concentration of H plus, and for POH, power for OH minus. We have studied that this pH scale is between 0 to 40. At middle we will have 7, right? Near to 0, that is acidic in nature. Near to 40, that is basic or alkaline in nature. Here it's 7, it stands for neutral. Means here the concentration of H plus will be equal to OH minus. Here the concentration of H plus is greater in comparison to OH minus. Here the concentration of H plus is less in comparison to OH minus. So this we have understood in pH scale. Also we have taken a knowledge that where this pH is important. So in that we have talked about how it is related with the animals and plants, right? Generally they have a proper rhythm in a certain pH range. So let's have a journey toward the importance of pH. Let's talk about importance of pH. First, in plants and animals sensitivity. Generally we know that the plants or animals, they have a certain pH range in that they can work very well. That's from 7 to 7.8. As we all know that the acidic gases are there in atmosphere, and by that rain, that acidic gases, it mix with the rain and it get down in form of more acidic rain. Now if the pH of it is less than 5.6, so that is considered as acid rain. And how this acid rain will be effective? We know that this acid rain, due to this acid rain, the organisms, whether it is plants or it's animals, so that it will get affected. Right? Not only on land, but this rainwater it mixed with the oceans and different water bodies. So the microorganisms and the organisms, the plants which is there in that aquatic life, so they will have a great challenge to survive. Right? So in this case also there is a great importance to maintain the pH. The second one is that this pH is important in our digestive system. Okay, in digestive system how? So we know that our stomach, it secretes HCl, and if there is more amount of HCl secreted, it will give us more acidic medium. In that case, there will be irritation in our stomach, which we know it as acidity. And in case of that acidity, we have to take different antacids, and generally they will be base. Okay, so the another one that it's also important in soil. How it is important in soil? We know that the crops will grow in certain pH range. If the soil is more acidic, so it will get burned, and if it is more basic, so they will not get a proper situation to grow. So here also in the soil, the pH range must be maintained. In tooth decay, we know that the calcium phosphate layer is there in our teeth, and if the acidic level of our teeth, if the pH it gets decreased in 6.5, right, so it can cause a tooth decay. How it is done? By the degradation of the food particles which is there between the teeth, which is stored between the teeth. It decreases the pH, it increases the acidic level, and our tooth will get decay. So in that tooth decay also, it's important. It is also important, as we all know, that in sting of honeybee and sting of metal bees, and in that we have studied that there will be methanoic acid. So as we are having irritation due to that, we have to apply the alkaline substance so we can get relief over it. So this way, pH is important in different areas, and that also we are going to prepare for. Now we will study about some of the important components like common salt, NaOH, bleaching powder, then baking soda, washing soda, plaster of Paris. And also we will talk about the one topic, that is water of crystallization. So let's start our journey. First is common salt, that we know, that NaCl. How is NaCl is formed? In the neutralization reaction, we can say like HCl plus NaOH gives us NaCl plus H2O, right? So the common salt, it is also obtained by the sea, okay? So it's a very common concept. This NaCl, the common salt, it is used as a reagent in many productions, right? So it's a very short, 1 mark of question can be asked from the common salt of cooking. Then we have understood about NaOH. Now how this NaOH is formed? In that we have studied that brine. Brine means aqueous saturated solution, right? When this brine is added into water, okay, the aqueous solution, means water react with brine and NaOH plus H2 plus Cl. Now it's simple how we can balance the chemical equation. Sodium 1, sodium 1, chlorine here 2. Now sodium is 2, so here will be also 2. Now if we talk about H2O, so 2 hydrogen and 2 oxygen is there. Okay? Sorry, 2 and 2, 4 hydrogen. So can I write here 2? Right? So as we have studied, and the figure was also there, the electrolysis. Okay? And in that case, what we have studied, that the positive anode and the negative cathode. Hydrogen, that is positive, so it will move towards cathode. It will be collected on cathode. And this chlorine, that was negative, so it was collected towards anode. Right? And NaOH was obtained from your nitrates. If you have remembered and if you have seen the video, then easily you can know that how does this reaction take place, right? So this is just a quick revision of it. So I have not explained it in detail. You can go throughout the video of our previous sessions in which I have explained that how NaOH is prepared, right? So it's simple. The brine reaction with the water and when electric current is passed from it, it will give us solution of NaOH. Then hydrogen and chlorine, it is removed. Hydrogen will be collected on cathode and chlorine will be collected on anode. Where NaOH, hydrogen and chlorine is used, that also it's explained in our video lecture, right? So we can go through it. Now, let's have how it is prepared. Slake lime, CaOH twice. We know that bleaching powder, slake lime, when from the slake lime, if chlorine gas is passed, we will get CaOCl2. This is our bleaching powder plus H2O. Where this bleaching powder is used, so generally we know that it is used in paper industry, it's used in textile industry, right? As a bleaching agent, it is also used as a oxidizing agent, also as a reactant, and it is also used to make water germ free. Okay, so this way, concept of bleaching powder is also important. Preparation of bleaching powder and uses of bleaching powder can be asked. So that also you are going to baking soda. How baking soda is prepared? So NaCl plus H2O plus carbon dioxide and plus ammonia gas. Right? So when it will react, it will give us NH4Cl, this is our ammonium chloride, plus NaHCO3. This is our baking soda, right? So this way, NaCl reacted with H2O, and from that, if carbon dioxide and ammonia gas is passed, right? So we will get ammonium chloride and sodium bicarbonate or sodium hydrogen carbonate, which is also called our baking soda. So the scientific name of it is sodium hydrogen carbonate or sodium bicarbonate. Okay, when we heat this sodium bicarbonate, it will give us Na2CO3. Right? When we heat it, it will give us Na2CO3 plus carbon dioxide plus water is released. Now, as we all know that this baking soda is used to make the pakoras crispy, also to make the cake spongy, and it's due to this carbon dioxide gas which is produced there. In process of fermentation, also the carbon dioxide gas is released, due to that it becomes spongy. So in baking soda also, by heating it, the carbon dioxide gas is released which make it spongy. Also we know that this is the alkaline substance, so it is also used as antacid, right? So it's used as an antacid. And third one, third use of it, that it is used in fire extinguishers, right? So this way, baking soda is also the most important compound. Its preparation and its uses is also very important in your exam. Okay, now let's talk about washing soda. Now what's washing soda? That we know that by heating sodium bicarbonate, we will get sodium carbonate plus water plus carbon dioxide. When this sodium carbonate, as we all know, that it reacts with 10H2O to gives Na2CO3 into 10H2O. Okay, so this will be our washing soda. Now try to understand here. Here, this is your water of crystallization. Right? That topic is also important. Not all the salts are dry. When we take any of salts in test tube and when we heat it, there will be a vapor, and that vapor will be of water. So you can take here the concept of water of crystallization. Here you can see that in one crystal of washing soda, there is one Na2CO3 and there is 10 crystals of H2O, right? That means whether you look it as solid, but then also it is not anhydrous. There is some level of water present in it, and this 10H2O is called our water of crystallization. Now, where this washing soda is used, generally we know that this type of washing soda it is used in GPS, in preparation of glass, preparation of paper, and in preparation of soap. It is also used in detergent, right? So it's used in detergent. Also it's used to remove permanent hardness of water. It is used to remove permanent hardness of water. So this way, washing soda is also the most important component, most important compound. Here we can understand about water of crystallization. Let us give you one another example. Suppose I talk about CuSO4 into 5H2O. That means in one crystal of CuSO4 there will be 5H2O. It means this H2O is always present in the crystal of CuSO4. So that is called water of crystallization. Here in this one whole compound, there is one of CuSO4 and 5 molecule of H2O. And this H2O is called water of crystallization. Keep this in your mind, right? It can be asked to you. Now, as we have understood about how there is preparation of washing soda and where washing soda is used, now let's go towards the last, that is our plaster of, let's go for plaster of Paris. We know that the plaster of Paris, gypsum, CaSO4 into 2H2O, calcium sulfates dihydrate. By heating that, we will get CaSO4 into half H2O plus 1.5 H2O will be released. Now this calcium sulfates half, so that is hemi. What it is called? Hemi. So calcium sulfates hemihydrate. It is considered as plaster of Paris. It's called plaster of Paris. This is the formula of gypsum. So how plaster of Paris is prepared, or the preparation of plaster of Paris can be asked to you. Now where this plaster of Paris is used, as we all know that it is used in decoration, it is used to prepare toys, also it is used by a doctor, right? Actually how it's used, so when plaster of Paris, it reacts with water, it will give a very hard substance, right? So that will be like a gypsum. Okay, so plaster of Paris, when it reacts with water, it will give us gypsum. When this dihydrate of gypsum, from that, if 3/2 H2 or 1.5 H2 is removed from it, and we will get calcium sulfates hemihydrate, right? Half H2 is there, so that is called hemihydrate. So that will be considered as plaster of Paris. So the chemical formula of plaster of Paris or the chemical formula of gypsum can be asked to you. Uses of plaster of Paris and preparation of plaster of Paris is also the important question. Also, in our chapter number 2's videos, we have described 2 activities. Yes, you remember that activities. That was metal reaction with metal, acid reaction with metal carbonate and metal bicarbonate, right? That one reaction was there. And also we have taken that how acid it reacts with metal, in that that can be also asked as a production of hydrogen gas, right? So that both activities are also you are going to prepare. Hope you have understood our second chapter, that is acid, base and salt. We have a quick revision in this chapter, right? And hope you all are preparing well, and that's true that you all are working very hard. We are receiving your homework regularly, and hope you are going to maintain it for the long time, right? So this way we have completed our revision of our chapter number 2, acid, base and salt. So be ready for the test. All the very best.